Hi guys, this is section 6.1, problem number 1. In this problem we are given different sets, and for each we want to determine whether one is subset of the other, and also need to determine whether one is a proper subset of the other. Now let's take a look at A. So this is the A. How do we determine one set is a subset of the other? As long as for any elements in set A, if all the elements are also in set B, that means A is a subset of B. If there's some elements that's in B but not in A, then we call A will be a proper subset of B, provided, of course, assume A is a subset of B. Now, let's take a look at what elements are in set A in this case. So I see a number, which is number 2. The second element in set A is a set. This set contains one element, which is 2. Now, this number, if you do the algebra, this is actually 2, right? So square root of 2 and then square, which is 2, which is repeating here. So this is not a new element. So basically, set A has 2 elements. First, number 2. Second, a set. This set contains only 2 in it. Now let's take a look at set B. Set B, I see 3 elements. The first element is a number 2. Second element is a set which contains 2. The third element is also a set, and this set contains a set 2 in it. Well, I can see that A is definitely a subset of B because I see for any both elements are in set B, right? And also furthermore, I also see set A is a proper subset of B. Why? Because in set B, this guy is not in A. This guy is not in A, right? So therefore, all the elements in A, they are in B. However, there's an element in B that's not in A. Therefore, A is a proper subset of B. Now, what about B? Because B has a element that's not in A. Therefore, B is not a subset of A. Okay, B is not subset of A. Therefore, definitely B is not a proper subset of A. Now, let's take a look at B. In part B, the set A, the first element I see is 3. Now, if you do the algebra here, 25 minus 16, which is 9, square root of 9, which is 3, right? This is actually 3. So these two are the same thing. So it's repeating. And the 24 mod 7, remember modular arithmetic, when you have something mod something, the result is just the remainder. So 24 divided by 7, remainder is just 3, right? 24 divided by 7, so that's the remainder. So remainder is 3. So therefore this is also 3. Basically, set A contains one single element, which is 3. Now take a look at set B, 8 mod 5. When 8 is taken away 5, you're left with 3. So the remainder is 3. They're definitely identical. So all the elements in A, they are in B. And all the elements in B, it's also in A. So therefore, A is subset of B, and B is also subset of A. Now, none of them is a proper subset of the other because you know, there's no element in B that is not in A. Similarly, there's no element in A that's not in B, right? So therefore, none of them is proper subsets of the other. Now, for part C, how many elements are in set A? I see 2 elements. The first one is a set which contains 1 and 2. The second one is another set which contains 2 and 3. I see 2 elements. They are both elements, they are sets. And what are the elements in B? I see 3 individual numbers, 1, 2, 3. So therefore, I can say A is definitely not a subset of B because I do not see any one of these 2 sets in B. Okay, so again, this will be considered one element. This element is a set. Okay, so in this case, A is a collection of 2 sets, and none of the elements in B, they are sets. So therefore, A is not in B. Similarly, I see nothing in B that's in A. Okay, B is not subset of A because I see 1, but there's no 1. There's no element of 1 in set A. You may argue, hey, 1 is in here. However, the elements in A is a is set. They're not individual numbers, so I don't see 1. If you had, say, 1 there, then I would say 1 is in A. There's no such elements, right? So therefore, none of these sets is the subsets of the other. Therefore, none of those is proper subsets of the other. Now take a look at D. I see 3 elements in A. They are A, B, C. I also see 3 elements in B. What are they? They are sets. The first set is a single element set that contains A. Note that this A is not in set B, right? Because this is a single element, that's A, and here they're not the same. This is a set A. So for that reason, I see nothing in A that's in B, nothing in B that's in A. So therefore, none of them is subsets of the other. Okay. So therefore, none of them is proper subsets of the other as well. Now for part E, square root of 16 is equal to 4. So I see 2 elements in set A. The first one is a single value 4. The second one, which is a set, this set contains a single element 4 in it. So element number 1, element number 2 in set A. And I can quickly conclude that A is not a subset of B because B doesn't have this guy, right? B doesn't have a subset which is subset of 4. So I do not see that here. However, I do see B is a subset of A because the element in B, which is 4, is one element in A. Now, B is also a proper subset of A because there's an element in A, which is this guy, not in B. So therefore, B is also a proper subset of A. For the last one, let's take a look at set A. Set A is collection of the real numbers such that cosine of the number here is an integer. Now this requires a little trigonometry, like cosine of what value is integer, right? Integer, and so the following is true. Cosine 0 is 1, which is integer. Cosine pi over 2, which is 0, which is also integer. Cosine of cosine pi, which is -1, integer. And cosine of 3 pi over 2, which is 0, also integer. And then for cosine, basically it repeats. If you look at the graph of cosine, it looks like this. Okay, looks like this. Extend to the left and right. These are the integer. This is 1. Here this is -1, and so 1, 0, -1, 0, and so on and so forth. There are many such values. So there are many such values there. Okay, so -1, 0. Well, with a little trigonometric knowledge, the x value that is 0, 0 plus or minus pi over 2, plus or minus 3 pi, plus or minus pi, plus or minus 3 pi over 2, and so on and so forth, because you also have the negative x values. Basically, this is every multiple of pi over 2, okay, where n is any integer. So that these values provide cosine x. Cosine of these values will be integers. Now similarly, if you look at sine x, being integer equals integer, okay, and then sine 0 will be equal to 0. Sine of pi over 2 will be equal to 1. Sine pi is 0. Sine 3 pi over 2 is -1. And sine of 2 pi, which is 0 again, and its graph looks like this. And extend left to and right? So all these points, all these x values, they correspond to integers, left and right. And it will be 0, pi over 2, pi, 3 pi over 2, and to the left is -pi over 2, and so on and so forth. Basically, if x is pi over 2 times n is any integer, then cosine of these values will be integer. Okay, so therefore here I'll just say this is pi. Basically, for x equals pi over 2n, where n is integer, and same here. Okay, same. Therefore, they're the same set. So A is subset of B, B is also subset of A, but they're not. None of them is proper subsets of the other because they are basically the same. All right, this is a little explanation for problem number 1.